Good morning, this is your Math Sensei, Mr. Spensei, and we're going to go over function notation and dependent and independent variables. First off, going to hit a couple definitions, then we're going to tell you a couple things you are going to need to memorize. And most of the times I say, hey, you don't have to memorize, but we are going to have to do some memorization. So relation's a set of ordered pairs. We've been working with that already, where the first of the ordered pairs are the inputs. In other words, the x's are the inputs and the second value are the outputs. So the x are the inputs, y, well, I didn't write that very well. X are the input and y are the outputs. Input, output. Function, a relation that assigns to each number exactly one output number. X cannot repeat. I think we know this by now. A function says X cannot repeat. Domain, it's all the input. In other words, it's the X's. So once again, domain is the X's. Again, we should know that by now. And range is the Y values. All right, range is the Y values. X's, and by the way, we have independent, the domain or the independent, the X's, and the range are the Y values. So let's look at this. So here's what you need to memorize. Independent variables, we have the X's, which is the domain, the input, the cause, and the cause, and I'll tell you what this means. So if we have independent variable, our dependent variable is y. If our domain is our independent, domain represents the independent variables, range is the dependent variable. The inputs are the independent, the outputs depend on the inputs, so they are dependent. F of x, that's just a function performed on x, and that really just means y. If that really just means y, guess what? Y is my dependent, x is my independent. This is the same as saying the cause and effect. So if we're reading a word problem, whatever's causing the change and the effect, the cause is the independent, whatever the effect is the dependent. All right? So independent, in this case, I'm using C as opposed to X, and I wrote G of C, and basically G of C is just, this is just another way of saying, hey, the function G performed on C. Anytime you see something like this is going to be your dependent every single time. This is like my Y variable. It's not a Y, it's a C. I mean, it's a G of C, the function performed on C, where C is like my X. C is my independent, and it's similar to an X. All right. So given the equation y equals 4x minus 3, complete the exercise below. Describe in a sentence what the equation is doing. So it also says give us a hint. All right. So let's make a table. All right. And I'm just going to do it on a calculator. I'm going to go y equals, and I'm going to press 4x minus 3. And I'm going to press blue table. And what do I notice is I'm like, oh, each one of these is 4 different. All right. So um, as x increases by, so the pattern is as x increases by 1, y increases by 4. And we can say, and when x is 0, y equals -3. All right. So we're always going to start with 0. Or initially, we'll just deal with the zeros. So it's like, oh, then we went 1 to 5 is 4, 5 to 9 is 4. So we're increasing by 4 because that's 4 times x. All right. So the independent variable, well, what is independent? That's going to be our x's. So the independent variable is x, and our dependent variable is y. Now it says write a dependency statement for the equation above. All right. So y depends on x and is 4 times x minus 3. Y depends on x and is 4 times x minus 3. Isn't that what we have? 4 times x minus 3? Because I could have just put these in parentheses, and parentheses means multiply. So 4 times x minus 3. There we go. The value of y is a function of our choice of x. In other words, every time we change x, y depends on it. And because we changed x, y is going to change on it. All right. The next thing, rewrite y equals 4x minus 3 using function notation. Well, function notation just means whatever this variable is, we're going to use f. So y is means equal a function of x. So all we're going to do is replace this y with f of x. So f of x equals 4x minus 3. That's all we had to do. All we did was replace the y with f of x. The function performed on x equals 4x minus 3. Please remember, f of x is the same as writing y. It's just this is in function notation. Okay, and up here, this was a different function notation, but g is performed on c, where c is my independent. Okay, so continuing on. For the equation negative 3x plus 7, complete the t-charts and the exercise below. Use the calculator for the tables. Well, let's do that. Let's speed through this. So this is something you need to get good at. You're going to go to y equals. By the way, use the little negative sign down here. Otherwise, it won't work. It's a glitch in the calculator. Negative 3x plus 7. You need to use the XTON button right here to get x. All right, use the XTON button to get x. And then we're going to press blue table. And look at this off to the side. All right, so press blue and then table. And we wanted a 0. Well, what did we have at 0? At 0, we have 7. At 3, we had negative 2. Let's go ahead and get 6. I'll go down to 6. We had negative 11. And at 9, we had negative 20. But I need to get all the way back and get to negative 3. So let's scroll up and get to negative 3, and we find 16. All right? Okay. But what if we were looking for the y values? Well, that means I'm going to have to scroll a bit. All right. So what I'm scrolling, I'm looking for 34. Oh, 34. All right. That means my x has to be negative 9. This means I needed a 19. Because remember, this just means y, and this also means y. And this is the function performed on 0. So when x is 0, we got 7. When x was 3, we got negative 2. When x was negative 3, we got 16. We see that there. F is 6. When x is 6, we get negative 11. When x is 9, we get negative 20. Here, we're looking for when y is 19. So I'm scrolling to get to 19. So when x is negative 4, and this could have been written f of negative 4. It could have been written that way. What do we get when x is negative 4? We get 19. When do I get 16? Well, I get 16 when it's negative 3. When do I get 10? When it's negative 1. And when do I get negative 5? And I get that when it is 4. All right. It says find f of x find y when f of x equals 9. Well, guess what? What does f of x equal? F of x is the same as saying 9, so y equals 9. All right? Now, if it said find x when, now a trickier one would be find x when f of x equals 9. So find x when y equals 9. Well, if I go to y equals 9, it doesn't show up on the table. So we're not going to worry about that right now because we're not going to worry about that type of problem. That gets a little bit ugly for what we're trying to do. But f of x equals 9, this means y equals 9, and it's already done. We didn't even have to do any work because remember, f of x just is the same as saying y equals 9. Using the calculator, find f of x when x equals negative 130. Well, I can scroll a long way to negative 130, and maybe you want to do that. Maybe you just want to sit there and go da, 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 and do that. But the easier thing, I think, because I mean, um, instead of sitting there scrolling all the way back to negative 130, would be going, you know what? X equals negative 130. Let's just plug it in. So y equals negative 3 times negative 130 plus 7. So let's use our calculator. Negative 3 parentheses negative 130 plus 7. And we get 397. So y equals 397. That's the same as saying f of x equals 397. All right, please remember f of x just equals y. Use the calculator to find f of negative 7. Well, what they're telling us here, remember that's like having f of x. They're saying, oh, x equals negative 7. Well, at that point, I can take my equation, and my equation was negative 3x minus 7. So negative 3 parentheses negative 7 plus 7. That's what f of x equals. So I'm going to just plug that in. Negative 3 parentheses negative 7, close them, plus 7, and I get 28. So f of x equals 28. Another way of saying it is what we wrote here. We could also write y equals 28, or we could write f of negative 7 equals 28. All right? All of those are equivalent. Y equals 28, f of negative 7 equals 28, because that's the same as saying y, and f of x equals 28, because that's another way of saying y. So we have all these different ways of saying y, okay? Using the calculator, find f of x equal to negative 35. Using the calculator, find x. All right, so first off, let's go back to y equals, and go back to, and we have negative 3x plus 7, and let's go back to our table. And we're looking for y equal to negative 35 and see if we actually get that answer. If it doesn't show up, it did show up on our problem. So we know that x, in this case, equals negative 35. Alternatively, he could have gone, well, f of x is y, so we have y equals negative 3x plus 7. That's y, so y equals negative 35. So negative 35 equals negative 3x plus 7. Now, at this point, we can either solve it by hand, or if you have Desmos available, you could go to Desmos and you could plug it in like this. You could plug in negative 35, squiggle, negative 3n plus 7. All right? If you plugged it in like that, it would solve it for you, and it would have told you what we got off the table, that x equals 14. All right, simplify f of x minus 7. This is a really tricky problem. So let's write down our original equation. Y equals negative 3x plus 7. But they're telling us instead of x, this is what we're plugging in. We're plugging in this. So y equals negative 3 parentheses x minus 7. That's what we're plugging in for the x plus 7. Well, now I have to distribute. So I now have y equals negative 3x plus 21 plus 7. So y equals negative 3x plus 28. But it's not really y, it's really f of x minus 7. I just pulled that straight down, equals negative 3x plus 28. Kind of a lot of work, but all we did was plug in, distribute, and then combine like terms. All right, plug in, distribute, and combine like terms. All right, on to the next page. I believe this is the last one for the notes today. Yes, it is. Oh, good, fractions. So for the equation f of x equals 3/4 x plus 8, complete the t-charts. Well, first off, remember, this is the same as saying y equals 3/4 x plus 8. And the reason that's important to remember that is because that's where you're going to go in the calculator. You're going to go to y equals 3 divided by 4, parentheses, use the XTON button, x plus 8, close those parentheses, and we're going to go to blue button, followed by the graph or table button. And the very first thing it says f of 0, so f of 0, so that means the function performed on 0. That tells us we're looking for x equal to 0. Excuse me for just a second. Thank you. So x equals 0. When x equals 0, y equals 6. This is telling me they want x equal to 4. Well, that happens when y is 9. Now they're telling me x equal to negative 4. And that happens when y is 3. Then they also want x equal to negative 8. That happens when y is 0. And then they say they want x equal to 12. And that happens when y is 15. All right. Over here, they're saying y equals 0, y equals negative 9, y equals negative 6. This is y equals negative 3. This is y equals 12. So let's see if we can find those values. So I see y, first off, I happen to see y equals 12. That happens when x equals 8. All right. And then scrolling down, looking for y equal to 3. That happens when x is negative 4. Looking for a 0. That happens when x is negative 8. Looking for a negative 6. That happens when x is negative 16. And looking for a negative 9. And that happens when x is 20. And watch what happens. All right, this isn't just magic. I could go and just quit out of that and go, okay, 3 divided by 4, parentheses. Instead of x, I'm going to put in negative 20 plus 8 and close those parentheses. And look, I get negative 9. So if I put in these values for x, I'm going to get these y values over here. Find f of y when f of x equals negative pi. Well, remember, what is f of x? Oh, that's y equals negative pi, because f of x is just plain old y, so I didn't even have to do any work. I just had to know my definition. Use the calculator and find f of x when x equals negative 124. Okay, So using our calculator, we have f of x equals 3/4 x plus 8. That's our equation. Remember, this is y. So y equals 3/4 times negative 124, plus 8. Close those parentheses. So y equals, let's not even do that. Let's go here. 3 divided by 4, parentheses, negative 112, negative 12, plus 8. And we end up getting negative 3. So f of x, and please don't forget, f of x just means y. Use a calculator and find f of 32. What that means is x equals 32. So once again, if we have our equation, we want f of 32 equals 3/4 x plus 8. This is f of x. Well, f of 32 equals 3/4 32 plus 8. So f of 32 equals 30. So in other words, y equals 30 when x equals 32. That's just saying y equals 30 when x equals 32. So I'm going to write y equals 30 when x equals 32. Use a calculator, find x when f of x equals 102. All right, this is probably when you're going to want to use Desmos. So let's go ahead. They're telling us f of x equals 102. So f of x and equals, and our equation is 3/4 x plus 8 in parentheses. And they're telling us 102 equals 3/4 x plus 8. So this is my y value. So I could just go to my table and I have y equals 3 divided by 4, parentheses, x plus 8, close them. And I'm going to look for 102. So I'm going to have to scroll down a long ways till I get to 102. Scrolling. See, I told you I had to scroll long ways. And if you don't want to do all that scrolling, there is a shortcut, and I'll show you that in just a moment, or I'll tell you how to do it in a moment. So in this case, when we solve this, we end up getting x equals 128. And we can go back and check ourselves. Let's do that. We have 3 divided by 4, parentheses, 128 plus 8, close them, and we get the 102. Now, the easy way to do this is at this point, once you've done this and go, oh, I have this equation, let's plug this into Desmos. So this is where you want to flip over and go 120, squiggle, 3/4 n plus 8. And if you did that, it'll tell you n equals 128, which you need to switch to x equals 128. The last one, simplify f of x minus 8. And by the way, this is going to be a little bit of a booger, especially if you hate fractions. So they're telling us our equation was f of x equals 3/4 x plus 8. But they're telling us f of x is function performed on x minus 8. So this is going to be the function performed on x minus 8 equals 3/4 parenthesis x minus 8 plus 8, close parenthesis, because all I did was plug in the x minus 8 for the x, because this value right here, that's my x value, and I just replaced it with x minus 8. Well, what's x minus 8 plus 8? Well, that becomes 0. So f of x minus 8 equals 3/4 x. These became 0. So 3/4 x. So f of x minus 8 equals 3/4 x. All right. Okay. A couple of those are a little bit rough, but I sure hope this helped. Look forward to seeing you on the next one.